Alright, lesson 6.1 is solving linear systems by graphing. And in this chapter you're going to solve systems in a slew of different ways, but we're going to start out with graphing. First, it's important that you understand what a linear system actually is. Sometimes it is called a system of linear equations, and sometimes it's just called a linear system. But it consists of two or more linear equations in the same variable. So if they're going to use x's and y's in one, they have to use x and y in the other. And here's an example of two equations that make up a system. They're both in terms of x and y. The solution of a system of linear equations in two variables is an ordered pair that satisfies each equation. So you have to use the same x in both and the same y in both and get a true statement that results. And again, one way to do this is by graphing. When you get to Algebra 2, you will do systems of linear equations in three variables. Okay, so in some cases they're going to give you a system and they're going to give you a graph, and they want you to use the graph to solve the system, but then check your solution. So the solution is where the lines intersect. So this is the point 3, -5, but we have to check it. So 3 is x, -5 is y. If I check it here, I have 3 subtract -5, which should equal 8, and it does because you have to add the opposite. So 8 equals 8, that checks. And then down here, 3 plus -5 should equal -2, and it does. So that's how you will look at it, tell what the point is where they intersect, and then check it. Now these next two are not going to be as nice and compact as that. We're going to have to work for this by actually graphing them, and we are going to graph these by putting them again in slope-intercept form. You should be experts by now in slope-intercept form. So this first equation, I'm going to go ahead, I'm just going to work it out up here. You can work it out wherever. I'm going to add the 3x, so I get -y equals 3x minus 1. Divide by -1, and y equals -3x plus 1. My slope is -3. My y-intercept is 1. So I'll go ahead and graph that. My slope is -3, so down 1, 2, 3, and back 1. 1, 2, 3, back 1, and then I need to draw my line, making sure that my arrows are at both ends. And then this next one I'll just put down here. I will subtract the 2x, so 4y equals -2x minus 16. Divide by the 4. So y will simplify this to -half x minus 4. So my slope is -half, my y-intercept is -4. So I'll come down to -4, my slope is -half, so I can go up 1 into the left 2 or down 1 into the right 2, and I can see right here that this is where my lines intersect. So my solution is 2, -5. And if I were to plug in the 2, -5 in here, they would it would satisfy both equations. Now let's try these. So the first thing I'm going to do here is add the 9x, so 6y equals 9x minus 6. Divide by 6, and y would equal 3/2 x minus 1. Again, my slope is 3/2, my y-intercept is -1. So up 1, 2, 3, and to the right 2, or down 1, 2, 3, and to the left 2. And this one I'll work out down here. I will subtract 2x, so -3y equals -2x plus 8. Divide by -3. Y will equal +2/3 x minus 8/3. So my y-intercept is, or I'm sorry, my slope is 2/3, and my y-intercept is -2 2/3. So -2 2/3 is right about here. And then if I go down 2, there's 1, 2, and then to the right 3, 1, 2, 3. It's right around here. And when I connect, It looks like they're intersecting right here at the point -2, -4. And again, I mean, it's a little tenuous. It's not perfect with my sketch, but if I were to check it up here, I can tell you 100% it does check out. It does work. Okay. Last one, hanging flower baskets. You will be making hanging flower baskets because